Alright, the last three examples we're now going to start using the formula for electric force determined by Coulomb's law. This is a very important force formula. Should be new to probably any of you unless you've taken Physics 30 before. And we really want you to understand that this is electric force as opposed to the other forces you've studied before. There's a really good comparison in your notes and in the workbook that talks about how the electric force formula is so similar to the Newton's law of gravity or the gravitational force formula. And there's a little bit of a comparison that tells you the similarities and differences. In Physics 20, you work with that gravitational formula quite a bit. Physics 30, we're just going to do a quick review of that gravitational formula, but we really apply electricity and magnetism in this course. But there are a lot of similarities. Both those forces could be attractive. Both those formulas, involve a 1 over r squared ratio. But gravitational forces depend on masses. Electric forces depend on charges. So the closer the charges are together, the greater the force. The larger the charges, the greater the force. Whereas when you think of the law of gravitation, the closer the masses are together, the greater the force. The bigger the masses, the greater the force. You know, the reason why we have such a large force of gravity on Earth is because the Earth is so big. Move to a smaller planet, there's less gravitational force. That is why, I'm sitting beside this desk. Both the desk and I have a mass, but the mass is so small in comparison to the Earth that I'm attracted to the center of the Earth and I'm not attracted to the desk. All right? The masses are just too insignificant. Well, let's apply that to, or the electric force formula to this question. We got a point charge of 0.475 microcoulombs. So I tend to draw a picture where possible. So here's my first point charge, Q1, and it has a 4.75 times 10 to the negative 6 coulombs of charge. It has a distance, 0.136 meters, from another point charge that is unknown. We'll call Q2. We have a force that's experienced between them, an electric force of 25.2 newtons, and it's attractive. So if it's attractive, that means one of these one of these charges has to be positive and the other one has to be negative. If they were both positive, it would be a repulsive force. If they're both negative, it would be repulsive. To get attractive, opposites attract. So we automatically know what the sign of Q2 has to be. To be an attractive force, Q2 has to be negative. Now, you might be wondering, why do they use R? Well, you have to remember that this is a three-dimensional force. These forces are actually experienced in all directions. So when we say R, R really does stand for the radius of the sphere of influence. So the distance between the objects is the radius of the circular sphere surrounding these two objects. So if we put the formula in, Fe, and this is in absolute value symbols, and the reason why we do that is we're just looking for the magnitude. We use the problem to determine the sign. Equals K, Q1, Q2 over R squared. And you'll notice in my notes, I tell you not to worry about putting in signs for Q or signs for Fe. We will use the problem to determine that direction after. You just plug in the numbers, the positive values of these numbers, and you determine the sign and directions after you do the calculation. What we need to do is manipulate this for Q2. So we're going to multiply by R squared. So Fe times R squared, and we're going to divide by KQ1 equals Q2. Let's put our numbers in. We have 25.2 newtons times the radius. Distance between these objects has to be in meters. Already is. Squared. And we're going to divide this. Now the K value is on your constant sheet again. Coulomb's law constant. 8.99 times 10 to the 9 Newton meter squared over Coulomb squared. And Q1 turns out to be 4.75 times 10 to the negative 6 coulombs. This is going to equal Q2. Put this off to the right here. Be very careful when you punch this in, because there's more than one number in the denominator. You have to bracket it. So go 25.2 times 0.136 squared, enter, divide by, and then go bracket. 8.99 to the exponent 9 times 4.76 to the exponent negative 6. Hit enter, and you should get 1.09 times 10 to the negative 5. 1 point, and if I go to 3 sig digs, 0.9 times 10 to the negative 5 coulombs. Or, if you want to go back to that unit of microcoulombs, Q2 is 10.9 microcoulombs. Either way would be fine to describe. You have the right sig digs and you have the right units. Now, we're not actually finished, because we need to get the appropriate sign on that charge. Because Q1 is positive, because the force is attractive, this should be a negative charge to make that an attractive force. So you put the sign in at the end. Watch out for that. You know, typical diploma questions will have this number positive and this number negative, and it catches about 40% of the students. They forget to check the charge or the sign on the charge by understanding what was the direction of the force. Because this is a force, it requires magnitude and direction.